So, hello, my dear student. How are you? Please tell me, is audio and video is clear? I think audio is clear. Am I audible? Let me clear one thing. Am I audible? Yes. Now the voice is clear, Manoj Kumar. Now the voice is clear. Now the voice is clear. Voice is clear, beta? Okay. So now I'm going to start the session. Okay. Now let's start today's session. This is a team Drona, as you know. So this is a question, my dear. Please try to attempt this question. It's a very easy question. Yes. So your answer is what? 720. Right. Good. So your answer is 7, 10, 20. Okay. At the end milling, having how many teeth? Question is very simple. How many teeth? Z equal to 6 teeth is rotating at RPM. This is the RPM N. If the feet per tooth is given, that is a load on the tooth. Right, the table feet in mm per minute. Very easy, straightforward. As you know, the table feet equal to what? Fz into, that is the feet per tooth, into number of teeth into RPM. So Fz is what? That is 0.3, right? Number of teeth is what? That is 6. And the RPM is what? That is 400, right? Mm per minute. Mm per minute. So 0.3 into 6 into 400. So it is 720 mm per minute. Right. Good. Very good. Now the next question. Now the next question. This is the next question. Yeah, please solve the next question. A hole of 20 diameter and 60 depth is to be drilled in a mild steel component. The cutting speed is given, that is of 50 meter per minute, and the feed rate is 0.4 per revolution. The material removal rate in cube per second is. Yes. 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 Yes, beta. So what will be the answer? Yeah, tell me. Yes. Okay. Now let me solve this question. It's a very easy question. Look, this is a workpiece, right? And a hole of what? 20 mm diameter and 60 mm deep. 60 depth is to be drilled in a mild steel component. The cutting speed is given to us and the feed rate is given to us, right? So the diameter is given, my dear, and the depth, depth is given, right? And the material removal rate. I think this will be the total machining length. This will be the total machining length, right? Yeah, सर मैं 11th में हूँ और मैंने अभी कुछ नहीं पढ़ा है और जेई की प्रिपरेशन कर रहा हूँ, सो प्लीज रिप्लाई सर. बेटा, right now you are in the 11th class here, right now you don't have any work, right? So we are doing questions of gate, right? So I'm very happy that our 11th class student is there in my class. He is such a motivated student. Huh? He is such a motivated student that he's present in my class. Wow. Okay. So the diameter is given. Yes, this is the diameter, my dear student. This is the diameter. Diameter is how much? That is a 20 mm, right? 20 mm. And machining length is what? 60 mm. LM is what? 60 mm. This is the machining length. I think so. Right. To be drill steel component, the cutting speed is given and the feed rate is that much. Now the machining time is very simple. Machining time is what? Machining length divide by f into n. Right. So you have the machining length and you have the feed also. You have the feed also. What do you mean by the RPM? Okay. So V equal to pi d n divide by 1000 Yes. So V is 50, pi, D is the diameter, that is what? 20. This is N divided by 1000. N. Okay. 50 into 1000 divided by shift pi into 20. So here number of RPM is 795.77 revolution per minute. Machining time. LM, that is 60. F, feed rate, that is 0.4 into 795.77. But he is talking about not a machining time, sorry. He is talking about the material removal rate. So the material removal rate will be pi by 4 d square into f into n, right? So here pi by 4 d square, that is 20 into feed 0.4 into 795.77. This will be mm cube per second, right? So shift pi by 4 into 20 square into 0.4 into answer. So how much is coming? How much is coming, my dear student? Yeah, tell me please. Okay, tell me how much you are getting. How much you are getting? So approximately nearby, it is what? 1, 2, 3, 4, 5. It is basically 999.407 mm cube per second. Right? Okay. A cutting tool has a tool life exponent is given. Again, it's a very simple question. A cutting tool has a tool life exponent n equal to 0.3. It gives a tool life of 50 minutes while machining mild steel workpiece at a cutting speed of 100 meter per minute. The tool life, if it is to be cut at a 30% higher cutting speed. Yes, if it is, if it is, if it is to be cut at 30% higher cutting speed is. So tell me, what is the tool life? What is the tool life? Yeah, there is too much less student. Yes, a cutting tool has a tool life exponent n, right? N is given. My dear, as you know from the Taylor equation, V1 T1 to the power n equal to V2 T2 to the power n, right? Right? It is given to us. It is given to us. And if the tool, if it gives a tool life of 50 minutes, okay, it gives a tool life of 50 minutes. So 50 minutes tool life is given. That is T1. That is what? That is the T1. That is T1. T1 is given. This is T1. It is given. While machining mild steel workpiece at a cutting speed of what? This is V1, which is given. The tool life, if it is to be cut at 30% higher cutting speed, 30% higher cutting speed. So, my dear, here the tool life, when the cutting speed V2 30% higher. So what will be the V2? V2 will be 30% higher. It means what? Initial is what? 100 meter per minute. So V2 is 30% higher. It means it is 130 meter per minute. It is 130 meter per minute. So V1 T1, right? V1 T1, that is 100 into T1, that is 50 to the power 0.3 equal to V2 T2 to the power 0.3. So here you will get the value of what? T2. Yeah, tell me. What is the value of T2? What is the value of T2? Yes. So approximately it will become 20.85 minute. 20.85 minute. This is the value of T2. Next question. Please solve. Yes. Tell me. What will be the answer? Yes. In an orthogonal turning of cylindrical tube of wall thickness, here the wall thickness is given. Let's say it is a H or it is T. Let's say, right? Let's say it is what? T. The axial and tangential cutting force were measured. This is axial and this is tangential. The measured chip thickness after the machining was found to be the measured chip thickness. So it is TC. The rake angle was 12 degree, alpha is given, and axial feet, that is Vx, is given to us. The rotational speed of the spindle, that is what? RPM, is given. Assuming the material to be perfectly plastic and merchant Merchant's first solution. The shear strength of the material is closest to. What will be the shear strength of the material? Right? So, is it clear that you need to find shear force first of all, and also you need to find the shear plane area, right? You need to find the shear plane area. For that, you need what? For that, you need, I think, you need what? You need phi. Phi is the necessary thing, because while you calculating the shear force, or while you calculating the shear plane area, you need the shear plane angle. This is the clear. Now let's calculate the shear angle first. So we know that shear angle equal to tan inverse r cos alpha 1 minus r sin alpha, right? R sin alpha. So here TC is given. So what will be the T naught? Is it T naught is given in the question? Let me see. Here TC is given, that is 0.6. Okay. So let me see whether it is given or not. Yeah. So here, my dear, this is what orthogonal turning. Orthogonal turning means what? Lambda. Approach angle is what? 90 degree. T naught equal to F sin lambda, right? And F, we don't know the F here. But T naught equal to what? F, because lambda is what? 90. So first of all, calculate what? Calculate the feed. Calculate the feed. Feet. That is what? That is tool feet divided by RPM. Then it will become mm per revolution. So what is Vx? Tool feet, 100 mm per minute. 100 mm per minute divided by RPM. RPM is what? 500. 500, right? Mm per revolution. Now, feet 0.2 mm per revolution. This is the feet. So T naught will be what? T naught will be 0.2 mm per revolution. R is what? Chip thickness ratio, that is T naught by TC. Here T naught is what? 0.2 and TC is what? 0.6. So R 1 by 3, right? R 1 by 3. So what will be the value of phi here? Tan inverse 1 by 3 cos of alpha, that is 12. 1 minus 1 by 3 sin of 12. Okay, 1 divided by 3. So answer into cos of 12 degree divided by 1 minus answer into sin of 12, shift tan inverse. So here phi will become 19.306 degree. Okay, 19 point. Now what will be the shear force, my dear? Here you can see Fx is given, right? And Fx is what? Fx is Ft sin lambda, right? And lambda is 90 degree. So Fx equal to what? Ft. So what will be the Ft? Here Fx is what? 110. 110 Newton. So now you have the value of thrust force and you have the value of what? This is the cutting force basically, right? This is a cutting force and it is given to us. Now we can find the shear force, my dear. So how can you find out the shear force? How can we find the shear force? Here the shear force equal to Fc cos phi minus Ft sin phi, right? So Fc is given, that is 1400. Let me calculate into cos of phi Okay, minus ft, that is 1100 into sine of phi. So here shear force is 957.577 Newton. Right. So this is a Fs. Now, well, what will be the tau? That is Fs by tau s, and Fs by tau s, that is Fd divided by sine phi. So sine phi will come here. Am I clear? Here tau naught Fs will be what? 957.577. Speed is given to us, that is 0.2. Right. Now what will be the depth of cut, my dear? What will be the depth of cut? Here the thickness of the wall which is given now. Always remember, whenever he is talking about turning of tube whose wall thickness is given, that wall thickness become what? That wall thickness become the depth of cut, that is T. So here this is 5 sine of phi, that is 19.306, right? So answer multiplied by sine of 19.306, right? So here tau naught equal to 316.58 megapascal. So 316. So the nearby answer is option D. Next question. Yes, next question. Here there are 200 steps on a stepper motor, right? The BLE of the table you have to find out. And in the figure it is clear that the pitch is what? Pitch is 3 and the number of start is double. From the figure it is clear, to the stepper motor you are providing some signal, right? Like 200 pulses. 200 pulses, okay, per revolution, right? 200 pulses you are providing. 200 pulses, right? 200 pulses, and here pitch is given 3 mm. Double start, that is what? Z, or number of start. Number of start is given, that is 2. Number of start is given, that is 2. So what will be the lead? What will be the lead? Lead will be the number of start, right? Number of start into pitch. Number of start is 2. Pitch is what? 3. This is 6 mm. It means after one revolution of the lead screw, there will be 6 mm. Okay, there will be 6 mm. Okay, translational motion. There will be 6 mm translational motion. Yes or no? Tell me yes or no. There will be 6 mm translational motion, right? So you can directly say that it means by giving 200 pulse, there will be one revolution, and after one revolution 6 mm translational motion is there. Or you can say that 200 pulse, if you give a 200 pulse directly, I can say that after giving 200 pulse there will be 6 mm translational motion. So what is the basic length unit? The basic length unit is, by giving one pulse, how much translational motion is there? How much translational motion is there? So that much mm is going to come. That much mm is going to come. So this is what? 6 by 200. Okay. Yeah. Tell me. 6 by 200. It is what? 0 0.03. 0 0.0. Yeah. Tell me. But it is in mm. It is in what? It is in mm. Right? You have to find in mm. I make it simple. You have to find it in mm. So it will become 0.03 mm. Right? 0.03 mm. 0.03 mm will be the basic length unit. Next question. Yes, please. Next question. Yes, please. Yes. Yes. The rating of the welding transfer. Okay, the rating of the welding transformer. Here rating is given, my dear. Here the current is given, voltage is given, and the 70% that is the duty cycle is given, right? And when 1500 ampere current is drawn from the same transformer, then what will be the duty? Then the duty cycle will be in the percentage. You have to find the duty cycle. Okay. As you know, in the case of duty cycle, in the case of whenever we talk about the duty cycle, right? Whenever we talk about the duty cycle, okay, duty cycle, there is a one relation, that is I square into duty cycle, okay, is what? Constant, right? It is what? Constant. Am I clear? Now, here two cases are given. So I1 square D1 equal to I2 square D2. I1. So I1 will be 1000 square. D1 is what? 0.7. I2 is given, that is 1500 square. Now you have to find the D2. Am I clear? So you will get the value of D2. Now let me see. So 1000 square divided by 1500 square. So it will become, D2 will become 31.11%. Right? Next question. Yes. Yes. Please solve this question. It is given that there is a U groove. Okay. Weld is used to weld a two-piece of 8 mm thick aluminum plate. 8 mm thick aluminum plate. The U groove is prepared using a milling cutter so that the diameter of the groove is 6 mm. During the welding, the penetration of the weld causes an addition of 1.5 mm of material to be melted. The final cross-section area of the weld can be approximated by semicircle. He's here at the at the end. He's finally basically assuming that final cross-sectional area is approximated. Okay, semicircle with a diameter of what? With a diameter of 10 mm. The length of the weld, the length of the weld is given, that is 100 mm. The melting factor of the setup is, this is the melting factor of the setup, that is what? 0.6. And the heat transfer factor, is given Tm for the aluminum is 100K, and Um is given, that is a specific heat, 3.33 10 to the power minus 6 joule per mm cube per Kelvin square. Right? So this is a thing. So first of all, let's concentrate to calculate the specific heat required. Right? A specific heat required. That is 3.33 10 to the power minus 6. 3.33 into 10 to the power minus 6. Right? Joule per mm cube. Joule per mm cube. Okay. Joule per mm cube Kelvin square. Right? 2000 Kelvin. So multiply, because aluminum melting temperature is given. Right? That much joule per. So this is a joule per mm cube, and it will become, my dear, 13.32 joule per mm cube. Joule per mm cube. So what is the required heat? What is the required heat? The required heat will be the specific heat into volume, right? Into volume of the weld pool. So what will be the volume of the weld pool, my dear? Here, please see. Here, please see. See here. Finally, he is saying that the weld pool is what? Semicircular. See, here length is given, my dear. So finally, the weld pool is what? Semicircular, right? So what will be the volume? This is the length of the weld pool, if I'm not wrong. This is the length of the weld pool, and the length of the weld pool is given. And how much is that? That is the length of the weld pool is 100 mm, right? The length of the weld is 100 mm. So this is 100 mm, my dear. This is what? 100 mm, right? And this is a weld pool having a radius, having a diameter 10 mm, right? Semicircular with a diameter 10 mm. So what will be the cross-sectional area? That is a pi by 2. The cross-sectional area is pi by 2 r square. Pi by 2 r square. So pi by 2 r is what? 5 square, right? 5 square, right? This is mm square. So this is the area, my dear, right? This is the area. Now what will be the volume? Here the volume of the weld pool, area into length, right? Area into length. 5 square into 100 mm cube. This is what? This is the volume. So multiply that specific heat, multiply that specific heat, 13.32 into volume is what? 5 by 4, 5 square into 100, right? Into 100. That much joule. So it will be what? It will be 13.32 into shift pi by 4 into 5 square into 100. So it will become, my dear, how much it will become? It will become 5. Yes. Yes. I hope the thing is clear. I hope the concept is clear. Right. I hope the concept is little bit clear. So what will be the volume, my dear? Here the volume is shift pi by 2 into 5 square, right? Into 5 square into 100. So 3926. This is the volume. Basically, volume is what? Volume is 3926. 3926.99 mm cube. So 13.32 into 3926.99 joule. Answer into 13.32. Okay. So what will be the required heat? Okay. What will be the required heat? That is 52307. 52307.51 joule. This is the required heat, right? Now the input heat will be what? What is the input heat? Basically here it is given that from the source, right? From the source, what will be the required heat generated? That we have to find out. We have to find out. So my dear, and the transfer efficiency is given. What is the transfer efficiency? Here the transfer efficiency is 0.9. So let's say, okay, we have to find out this. So what will be the, it's the melting efficiency, and this is what heat required divided by heat input, right? So heat required is what? That is 52307.51 divided by 0.9 times of, okay, the power which is we giving, or the heat which we are giving, the heat which we are giving, and this is equal to what? The melting efficiency is also given, that is 0.6. That is 0.6, right? That is what? That is a 0.6. So what will the heat that you are giving? Answer divide by 0.9 into 0.6. Yeah, so 52307.51 divide by 0.9 into 0.6. It is coming, my dear, 96. Okay, the heat which is required to transfer, that is 96865.75 joule. I hope the concept is clear. Now the next question is, yes. Now the next question is, now the next question is, yes. Yes. A stepping motor with 200 step angle is coupled to a lead screw through a gear reduction. There is a gear ratio. This is a gear ratio. RG is a gear ratio, my dear. That is 4 by 1 is given. It means that 4 rotation of the motor for each 4 rotation of the motor for each rotation of the lead screw. I mean, if the motor is going to rotate 4 times, then the lead screw is going to rotate 1 time. Clear? The lead screw has 3 threads per centimeter. Sorry, the lead screw has 3 threads per centimeter. From that information, I can find out the pitch. So pitch is what? Basically, after covering the after covering the 3 thread, you are moving some centimeter. After covering 3 thread, you are moving some centimeter. After covering 3 thread means you are doing 1 revolution. So it means that 1 by 3, right, that much centimeter per revolution will give me the pitch, right? So it will be 1 by 3, 0.33, 0.333 centimeter per revolution. So here is the pitch, 3.33 mm per revolution. This is the pitch. The work table driven by the lead screw must move a distance. Okay, must move a distance 30 centimeter. This is a distance which you want to move. This is a distance which you want to move at a feed rate of what? At a feed rate is given, that is a 80 centimeter per minute. This is a feed rate by which you want to move, right? By which you want to move. This is a feed rate. Okay. So this is what? This is a feed rate. Determine the number of pulses required to move the table and required motor speed respectively. So my dear, you have to find out the number of pulses, right? So the required number of pulses, that is NP, I gave you a formula, that NP equal to 360 degree into X into RP, RG, sorry, 360 degree into X into RG divide by P into alpha. Divide by P into alpha. So 360 into X. Now here X, that is a 30 centimeter. I am converting in mm. RG is given, that is 4. Divide by pitch, that is what? 3.33. 3.33 alpha. Now we have to find out the alpha, right? So alpha is what? Alpha is what? Alpha basically 360 degree divided by 200. That is the alpha, right? That is alpha. So it will become 1.8 degree. Means that much degree for 1 pulse, right? So 1.8. So you will get the required number of pulse here. So nearby it will become out 7207. Now, my dear, he wants to know the required motor speed. First of all, find out the lead screw speed. First of all, find out the lead screw, right, speed in terms of RPM. He's talking about the RPM. So the lead screw RPM is what? Here the table feed is given. Here the table feed is given, my dear, right? And the pitch is given. So the table feed is 80 centimeter. Now convert it into mm. So 800 mm, 800 mm per minute, 800 mm per minute divide by the pitch, that is 3.33 mm per revolution. So what will be the screw RPM? It will be 800 divided by answer into 10. It will be 240. It will become 240. It will become 240 revolution per minute, right? So what will be the motor RPM? Motor RPM is 4 times of what? NS, because RG is given, right? So 4 times of 220, answer into 4 times 960. 960 RPM, my dear. 960 RPM. So this will be the correct answer. Next is, it is required to cut. Next question. It is required to cut a screw thread of 4 pitch. This is the pitch which you want to produce on the given workpiece, right? On a lathe, right? The lead screw has a pitch. The lead screw has a pitch. The lead screw, this is the pitch of the lead screw, right? That is L. If the spindle speed, that is the speed of your spindle or your workpiece. So this is the spindle speed of your workpiece. Then the spindle speed of the lead screw, spindle speed of the lead screw. My dear, you know the given relation. That is the relation is what? The spindle speed into pitch of the workpiece into number of what? Number of start on the workpiece which you want to produce. Speed of the lead screw into pitch of the lead screw into number of start of the lead screw. Here NS is what? 100. Pitch is what? 4. ZS. Number of start is not given, right? So we will take one minimum is what? 1. Here NL we have to find out. L is given, that is what? 10 ZL. It is also not given here. So you have to consider that it is what? ZL is what? Let's say ZL is what? 1. So 0, 0. So what is the RPM? That is 40 revolution per minute. 40 revolution per minute. So the answer is what? Option B. Next question. In an electrochemical machining. Next question, please. Next question. In an electrochemical machining, right? Yes. Next question. In an electrochemical machining operation, the frontal working area of the electrode. Here the area of the electrode is given, right? Area of the electrode is given. That is 2.5 inches square, right? The applied current, how much? That much current, 1000 ampere, and the voltage is given. This is a 10 volt. The material being cut in a pure aluminium whose specific removal rate is given inch cube per ampere per minute, right? Inch cube per ampere per minute. If the ECM process has 85% efficient, the rate of metal removal is, right? Here conversion is also given. If you don't know, that is 1 inch equal to what? 25.4 mm. Okay, so let's start this question, right? Let's start this question. So what will be our approach? Here voltage is given, a specific machining is also given. So first of all, I think you have to find out what material removal rate. You have to find out the material removal rate. So here C is given, right? Here C is given. That is inch square per ampere into minute. So multiply it with the current. That is 100. It will become inch cube per minute, my dear. It will become inch cube per minute. Leave it. Now what will be the value of C? The value of the C, 0.0, 0 and 0, 126 into 100 inch cube per minute. Inch cube per minute, right? So here the efficiency is also given, 85. So the effective, okay, so the effective material removal rate basically is what? The effective material removal, that is the efficiency, into your 0.0000126 into 1000 inch cube per minute, right? Inch cube per minute. So what will be the value? Here efficiency is 85. So it is 0.85 basically. 0.85 into 0.000126 into 100, right? So it will become 0.1, right? Or leave it as it is, right? Leave it as it is. So this is the mm cube per minute, right? This is the mm cube per minute. Okay. Mm cube per minute. Oh no, this is the inch cube. So this is the inch cube, right? This is what? This is the inch cube. Now convert it into the mm cube. 25.4 cube. Now it will be 1755. 1755.05 mm cube per minute. This will be the effective MRR, right? This will be the effective MRR after the efficiency, right? This will be the effective MRR after the efficiency. And what he is asking, the rate of metal removal is, yes, he is asking this much. So this is the correct answer, right? This is the correct answer. So that's it for today's session. Thank you very much for your love and for your support. Even my backend team supported me very well. So thank you very much. And as you know, this is our team Drona, right? And you know that today I have covered the manufacturing process too. Okay. Now tomorrow there is a fluid machinery plus turbo machinery is going to taken by Amit Maurya sir. Okay. On Thursday, 26 January. The strength of material, time will be the same, right? The strength of material is going to be taken by Apurva sir on 27th of January. Heat transfer is going to be taken by Sandeep Chandrakar on Sunday, 28th of January. Thank you very much, my dear student.